All right, so 3.3, talking about rates. And the diagram given in the data in the given table shows the number of motor vehicle deaths, MVD. We're going to use that in abbreviation for, in a certain country as different rates. Use information to complete A and B. So the table right here is where we'll get our numbers from. So once again, it's this little blue square right here. If you haven't gotten in there, notice that the resident populations in thousands, then vehicle miles traveled is in billions. So make sure you are careful with that, and you'll see what I mean when we go into our calculations. All right. So let's share. My notes go. All right. So let me erase some of this stuff. Compute the fatality rate per 100,000 population in 2001. So we're going to take the number of motor vehicle deaths in that chart. So you would go to the chart 2001, get the motor vehicle deaths 2001, and over the number of people in 2001, and it's in thousands. So the numbers I had from the chart that they gave me was 41,998 motor vehicle deaths, and then the population in thousands, 249,663. So thousands means that really what you could do is take the number that they gave you and add 3 zeros to the back. That would be 1,000. So this is a number that we actually would be calculating with. So it's 663,000. All right, divide that out. You get 0.001682 motor vehicle deaths per one person. All right, so before we go to the next step, questions on what I've done so far? Okay, now you have to consider how do they want the answer. They want the answer per 1,000, or 100,000, excuse me, per 100,000 population. This is per one person. So what I would do is multiply both numbers, top and bottom, by 100,000. So I can have 100,000 people down bottom as a population. And so that would be 16.82 per 100,000 people. When you go to my math lab, the only number they want is this one right here. But it will represent 16.82 per 100,000. They want to know how many. When you go back to, see, it already says what's the fertility rate per 100,000. So it would be 16.82. You do not have to put the 100,000 in there. All right. Questions on that before we go to B? B, compute the fatality rate per 100 million. So this time we're looking at per 100 million. Vehicle miles traveled, VMT, in 2014. So you would do the number of motor vehicle deaths over the number of billion vehicle miles traveled. Remember, when you go to the chart, vehicle mile travel is in billion. And so that's 32,189 over 2985 billion. And so here I was just giving people a reference on how many zeros you would use for each 1,000. You would use 3 zeros. Million, you would use 6 zeros. And then billion would be 9 zeros. So I take that 2985 and put 9 zeros behind it and divide it into that 32,189. And I get this value of I think I got 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros in front of that one. You know, and oh, let me erase that error. That was something that somebody had asked me about. That had nothing to do with anything as far as the problem was concerned. So that's 7 zeros in front of that one. Then it's 107836. All right, questions before we go to the next part of this one? Because remember, this is per one person. Once you divide that 2985 billion into the 32,189, that's per one person. We want our answer per 100 million. So that means we need to multiply top and bottom by 100 million. That's 100 with 6 zeros behind it. So it'll be 8 zeros altogether behind the one. So when you multiply top and bottom by 100 million, you get 1.08 motor vehicle deaths per 100 million people, or the population, 100 million population. All right, questions. All right. Oh, let's go back to the homework. So next one, suppose that in 2008, 847,800 citizens died of a certain disease. Assume the population of the country is 363 million. What is the mortality rate of units of death per 100 people, 100,000 people? So let's go to the numbers that I have. So we are looking for deaths per 100,000 people. Let me erase some of this stuff. So we have our deaths set up per 391 million. So we need to convert our million to 100,000 people. So the way we can do that, and this is what we have initially, they gave us 635,150 deaths per 391 million. So what we can do is use a conversion factor of 100 million over 10 groups. If I were to divide, I'm not 100 million, 1 million over 10 groups. If I were to divide 1 million, that will equal to 100,000, which is what I'm looking for here. So I would do 1 million over 10 groups. So that means each group will represent 100,000. Because remember that the reason why I need this is because when I set up my conversion factor, if I have millions down here, I need millions up here. So that'd be 1 million over 10 groups. And that allowed these millions to cancel. And so if I go down to the next step, that's 635,150 times that one on top, 391 times 10 down bottom. Divided out, I get 162 deaths per group. And remember, each group is going to represent 100,000 for us. So it's 162 deaths per 100,000 people. All right. Questions on what we did there? Make sure we're okay.
I have a question.
Yep.
So I'm like plugging in these on the homework as we're going, and it's telling me that these are the wrong answers.
All right, so what are your, well, no. Now these numbers are different than your numbers.
Okay.
Yeah, your numbers will be different. You'll get a
So
different chart. You just have to follow the same process
so
though.
this is the same like formula though, like same
Yes,
process.
right, exactly. If you follow the same process, you'll get the right answer. But
Okay.
yeah, my numbers are going to be different than yours.
Okay. Thank you.
Yep, no problem. Thank you for asking. Some people would have just took the L. Glad you got clarity. All right. So let's look at number 3. There are approximately 3.3 million births in a country each year. Find the birth rate in units of birth per minute, births per minute. All right. So let's go back. So in mine, and so mine is 1.9 million. And just to reemphasize what your classmate was asking, I have 1.9 million births per year. How many births per minute? If you go back to the problem I pulled up, this has 3.3 million births. So yeah, you guys will have different numbers, but the question will pretty much be the same, and the process will be the same. And that's why I'm not necessarily going to do all of your problems, because I don't want to give you the process to every single problem, because I want you to try some of these problems out organically and see if you have any issues. But any questions that you may have that may come up and you do want to discuss, always feel free to bring them up to class or email me. Also, don't forget, you do have these help me solve this, and view an example. Most people like to do view an example and stuff like that. So you have all these things at your disposal. And as I mentioned before, office hours and everything like that, if you want to set them up, shoot me an email. We'll handle it from there. So let's go ahead to the problem. 1.9 million births per year. How many births per minute? So I'm going to erase this and walk through it though. Make sure we're good. All right, so we have 1.9 million births per year. We know that as far as a year goes, 1 year is equal to 365 days. 1 day is equal to 24 hours. And then 1 hour is equal to 60 minutes. So that's how we do that, so that we can connect year and year, which will cancel for us. Days and days will cancel for us. And hours will cancel, leaving us in minutes. All right. Everybody okay with the conversion before we look to multiply? Went to 365, then 1 day is 24 hours, and then 1 hour, 60 minutes. And we stopped at minutes because we wanted to end in minutes. All right. Then going back to the 1.9 million, that 0.9 is going to take away one of your zeros. Now, if it was 19 million, then that would be 19 with 6 zeros behind it. But I had 1.9 million. So that 0.9 is going to take away one of your zeros, but then you have 5 zeros after the 9. So just be careful with that. Same thing as if I had 2.93 mil, that 93 would take away 2 of my zeros from the 6. You know, my million is going to be 6 zeros. All right. So that means we have 1.9 million divided by 365 times 24 times 60. Multiply 365, 24, and 60, you get 525,600. Divide that into 1,900,000, and you get 3.615 births for every 1 minute or per minute. And my math lab will let you know how many decimal places they want, of course. All right. Questions? Any questions? before we look at the next one. All right. Number 4, if your car gets 35 miles per gallon, how much does it cost to drive 450 miles when gas costs $3.20 per gallon? All right, so mine was 32 miles per gallon. How much does it cost to drive 450 miles when your gas costs $3.50 per gallon? All right. So we want to convert our miles. We have 450 miles, and we have this conversion factor of miles per gallon. So if we do our connection, remember if we have miles on top, we use miles on bottom. So what we're going to do is convert the 450 miles to gallons, and then we'll convert our gallons to dollars. So this miles over miles will cancel, leaving us in the measurement of gallons. But then I also have this conversion factor of 350 or $3.50 per gallon. So I can use that right here. And the gallons can cancel and leave me in dollars, which is what I wanted. Remember, how much does it cost? All right. So now if I do my multiplication, that's 450 times 1 times 3.5. Then on bottom, all I have is 32 times 1, which is 32. Then go ahead and divide that out. It's $49.22. And since we're dealing with money here, it's assumed that you would go to the hundreds place for cents. All right, questions. All right, let's look at a few more. All right, here, decide which of the two given prices is the better deal. So we have shampoo in 2 different size bottles. So shampoo, we have 4 ounces. We have a 4-ounce bottle for $5.79. Then a 16-ounce bottle for $13.99. So when we do our comparison here, we can set up our ratio one of 2 ways. Either we can set it up as cost per ounce or ounce per cost. Now we want to be able to properly articulate and think about how we actually converse and how we actually process different things as we go throughout the grocery store. And we always are thinking about cost per something. How much is it going to cost for something, or how much is it going to cost per this? So cost, didn't need to do that. Cost per ounce would be the better comparison for us. So that means we're talking about cost over ounces when we go to set up our comparison ratio. All right. So we do that for both relationships. $5.79 over 4 ounces will be $1.45 per ounce. Then $13.99 over 16 ounces would be would be 87 cents per ounce. And of course, that means that would be the better buy. So the best way to set up your ratios is cost per. And that last one, we're paying less per ounce than the first one. All right. Questions? Any questions? So we got 15 problems in here, so 6 should be good enough to get you. That's almost half. Should be good enough to get you guys rolling. Like I said, I don't want to do all of your problems, but if you do come across problems that you have questions on, always feel free to ask. But I do want you to experience the organic, you know, uh, interaction with the problem versus, coming into it already knowing how to do it. So this number 6, the Greenland ice sheet contains about 3 million cubic kilometers of ice. If completely melted, this ice would release about 1.9 million cubic kilometers of water, which would spread out over the Earth's approximate 338 million square kilometers of ocean surface. How much would the sea level rise? All right, so the information that I start off with is I have 3 million cubic kilometers of ice, 2.9 million cubic kilometers of water, then 346 million square kilometers of ocean surface. How much would the sea level rise? So the first thing we want to recognize is that since the sea level is a height, our answer has to be in kilometers or kilometers. So notice that we have here, and I pointed it out, that the cubic measurement, the cubic kilometers, means that you're in volume, and the square kilometers means that is in area, surface area for the ocean surface. So we need to have our height though in regular measurement, which is kilometers or kilometers, no squared, no cube. All right. So what we would do is that we would take that 2.9 million cubic kilometers and place it over the 346 million square kilometers. The 2.9 over 346 will give us 0.008. The millions would cancel. And then we have cubic kilometers over squared kilometers. And the two, and so like I was explaining before, oh, there it goes right there, I left it up. Like I was explaining last class, if something is cubed, that means it's multiplied by itself, multiplied to itself 3 times. If it's squared, it's multiplied to itself twice. So if I have cubic kilometers over kilometers squared, 2 of those kilometers will cancel, leaving you with 1 left. So that's what happens here. So the 2.9 over 364 is 0.008 kilometers. And that's all you need. So that first piece of information they gave us, we didn't need, but we took the 2.9, divided by the 346. All right. Questions on that? Any concerns? All right. So that is it for chapter 3. Make sure you guys are getting in there. Remember, we have a midterm coming up. I don't know. Can we call it midterm according to? I got to see what as far as dates are concerned. I think we'll be a week behind as far as the dates are concerned, but that doesn't matter. It's midway through our lecture and new materials, so it's still our midterm. Um, it will be on chapters 1 through 3. We talked about that already. So if we were to look at a calendar as to the dates that are coming up, this week we covered 3-3 and 3-4. I think we flipped those days though. Covered 3-3 and 3-4. Next week we will cover new material. We talk about chapter 4. Don't know how many sections in which order, but 12 and 14th, the 12th and the 14th will cover chapter 4 material. Then the 19th, which is not next week, but the week after next, the 19th will be a review day. I will not cover anything new. I will leave room for you guys to ask whatever questions you want to ask. It's up to you to take advantage of that. I will not come with questions. Remember, I told you I will create a review to help you to streamline your studies, let you know what type of problems you should be looking at and everything like that. Then from there, oh yeah, so on that day, like I said, I won't come with questions. I'm always going to assume the best. So if you don't have any questions, I'm going to assume that means you guys got it. Also, that day is, I guess you can see it as being optional, because if all I'm asking you to do is ask questions, if you do not have any questions, you feel like you are good, then you don't necessarily have to show up that day. It'll just be for those who have questions or may feel like they can benefit from others, having questions. So that's what the 19 will be about. I will not cover anything new on that day. It will just be about chapters 1, 2, and 3, and what questions you guys have from those chapters to prep you for the next class, which will be the midterm. And don't forget, on that day, make sure that your camera is on so that I can see you all. It will be recorded. Make sure you stay in front of the camera. Make sure you bring your student ID and all the good stuff like that, so it can validate, it's you and all the good stuff. So, questions on anything I've stated, how we're gonna do things moving forward, and so on. Anything, anybody, everybody good? Questions on anything as far as your assignments, concerns, comments? You good? Everybody straight? Straight. All right. So I'm gonna assume you guys are good. So they said we got time, but we're done with chapter 3 since it's a closeout. I won't push and put anything in there. We close out chapter 3, so we can stop right here on today. With that being said, have a good weekend. I'm going to try to create that review between today and tomorrow, so you can start looking at that. Yeah, and let's just start getting ready for this midterm. So if you don't have any questions, I will see you guys on Monday. Have a great weekend and be safe.